I won't answer questions on the test quite today. I want to give you guys some time to look them over. So Wednesday and Thursday, if there's questions on them, I'll answer those. Otherwise, we'll see how it goes. If we have a lot of free time at the end of class today, maybe we'll take a little bit of time on them. I'd like you to have a little bit of a chance to look them over first. Okay, so today we're actually going to do some things that are kind of review from things we've looked at before. The first thing I want to look at is story problems. And looking at story problems, things that have like maybe a definite formula. Like one formula I might give you is a simple interest formula. The amount of interest on an account is equal to the principal times the rate times the time. Now, some things you might need to know off of this. P is the principal, which is the starting amount, the initial amount, or whatever you want to tell her, the amount at the beginning of the period. R is the rate. The rate is a percent as a decimal. And T is time, and time is always given in years for this formula. So just an example of how this formula would work. If you invest $4,000 at 7% for 3 years. To find the amount of interest, it's the principal of 4,000 times the rate of 7% as a rate that's 0.07 times 3 years. Comes out to an interest of $840. So that's your amount of interest. Now, the next step of that, if you wanted to, you could find the balance in the account. You'd have to add that 4,000 you started with, your principal, to your interest. Well, what we're concerned about today is how do you use that formula in problem solving? You might ask, find the rate. Well, let's actually look at. Here I gave you that time in years of 3 years. What if I didn't give you the time in years? What if I gave you months? Find the interest on $8,000 at 3% for 4 months. Well, now the interest is still the principal. In this case, it's 8,000 times the rate. 3% becomes 0.03. The difficulty is the 4 months. We said time is always expressed in years. How many months are in a year? 12. So 4 months is 4/12 of a year. So that comes out to $80 in interest. Again, we could add that on. I'm not going to bother here because it's not really the purpose of what we're doing. We might be asked, find the rate if a $5,000 investment gives, let's see, $1,000 in interest in 4 years. So here, it's still interest equals principal times rate times time. But in this case, we know the interest is $1,000. The principal is $5,000. The rate says find the rate. The rate is what we're looking for. We're going to call that R. Our time says 4 years. That's just 4 that goes in there. Now remember, when we solve equations, the first thing we have to do is see if there's anything we can combine on either side of the equation. Well, in this equation, there is. We have the 5,000 times 4, which is 20,000. The left side, the 1,000 doesn't change. So we've got 1,000 equals 20,000 times R. And we will divide to solve for R. Divide by 20,000 to get rid of it. So 1,000 divided by 20,000 gives us 0.05 for R. Now remember, that's a rate. 0.05 stands for 5%. What do you think? So let's look at this. How long does it take to earn $450 in interest on a $3,000 investment at a rate of let's go 5%. I'm going to have you guys try that in your notes, see what you come up with. We'll go over it in a minute. Okay, so we set this up. I always tend to rewrite the formula, so I make sure I plug everything in the right spot. So I equals PRT. I is the interest of $450. P is the principal of $3,000. R is our rate, 5% becomes 0.05. And we are looking for T. So we're going to combine the 3,000 and 0.05. Here's 150. So the $450 in interest equals 150 times T. We divide by 150. 3 equals T. So that means it's 3 years that it'll take to earn $450 in interest. Find the principal on a loan if 6% interest gives $90 in interest for the month. I'm going to have you guys try that one quick. So once again, I equals PRT, principal times rate times time. We know the interest of $90. This time we're looking for the principal. Our rate, 6%, so 0.06. And our time for a month, how do we write that in? 1/12. Very good. So now we are going to combine what we can on the right side here. 0.06 times 1/12 is 0.005. So to solve for P, we divide by 0.005. We get $18,000 as our principal. Any questions on those problems? Okay. Now, another type of problem that we did was our perimeter, where there was a formula, was our perimeter problems. We had the perimeter equals 2 times the length plus 2 times the width. And we can get increasingly difficult with these. We might have a rectangle has a length that is 7 more than the width. The perimeter is 134. Find the length and the width. So I like to draw a rectangle on these. It's just easier for me to keep track of stuff. I have the length and I have the width. My formula, perimeter, is 2L plus 2W. I know the perimeter. That's given up here. P is 134. But I don't know the length or the width. I have to find both of them, but I don't want to have two variables. So I need to write one in terms of the other. And I see up here it says the length is 7 more than the width. So the length is the width plus 7. So now I can get this down to one variable. I replace P for perimeter with the 134 equals 2 times L. I place L with W plus 7 plus 2 times the width. So now you can see W is the only variable in this anymore. So we go to solve. Once again, we have to simplify everything we can on one side. So on the right side, we have 2 times W is 2W. 2 times 7 is 14 plus 2W. We can still combine over there. The 134 won't change. We can combine 2W and 2W to get 4W. Now we've combined everything we can. The next thing we have to look for is if the variable appears on both sides. And for this equation, it does not. It only appears on the right side. So we can go ahead and start solving. So what do we do first to solve this? Subtract 14. So 120 equals 4W. And then divide by 4. So 30 equals W. Now we have to make sure we go back and answer the question. W equals 30. Well, W is just the width. But we want to find the length and the width. Well, the length is W plus 7. So that's 30 plus 7 or 37. So we have the length is 37 and the width is 30. We might have the length of a rectangle is 5 times the width. The The perimeter is 300. Find the length and the width. I want you guys to try that one in your notes. Okay, so again, I like to draw the picture. And I'll write my formula. Now the relationship is the length is 5 times the width. So the length equals 5 times W. So let's put in what we know. Perimeter P is 300 equals 2L, so that becomes 2 times 5W plus 2W. Well, we gotta combine what we can on the right side there. 2 times 5W is 10W. 10W plus 2W combines to be 12W, and now we just have to solve by 12. So 25 equals W. The width is 25. The length is 5 times 25, or 125. Any questions? I want you to try this one, see what you come up with. The length of a rectangle is 7 more than twice the width. The perimeter is 134. Find the length and width again. So let's see if you can figure out what to do with that one. So once again, I'm going to draw a rectangle. We've got a length and a width. Now this time the length is 7 more than, that means 7 is being added to something, then twice the width. So it's 2W. So L is 2W plus 7. So we look at our formula. Perimeter is 2L plus 2W. The perimeter is the 134. 2L becomes 2 times. L is replaced with 2W plus 7 plus the 2W. We can combine what we can on the right side there. 2 times 2W is 4W. 2 times 7 is 14 plus 2W. And then 4W and 2W is 6W plus 14. Now we've combined everything we can combine. The variable does only appear on one side, so we can start to solve by subtract 14. 120 equals 6W, and then divide by 6. 20 equals W. So W is 20. L is 2 times W, 2 times 20 plus 7. That's 40 plus 7, or 47. So those are just a couple of different examples where if we're given a formula, we can use that formula to solve problems. Other problems we can look at are problems where one thing builds on another. For example, we might have Steve is 6 years older than Pete. Kate is 4 years younger than Pete. The sum of their ages is 29 years. Find their ages. Well, we've got Steve, Pete, and Kate. Now it says, I'm going to represent their age, obviously. Steve is 6 years younger than Pete. So if I let Pete be P, Steve is 6 years older, P plus 6. Now it's convenient here. Kate also references Pete. Kate is 4 years younger than Pete. So Kate would be P minus 4. The sum of their ages is 29 years. So I add them up. Steve is P plus 6 plus Pete, which is just P, plus Kate, which is P minus 4, has to add up to the 29 years total. Now, of course, I can combine here. P, and P make 3P. Positive 6 and negative 4 make 2. So 3P plus 2 equals 29. So I've combined the variables only on one side, so I can go ahead and solve by subtracting 2. 3P equals 27, and then divide by 3. P equals 9. Now again, I have to answer the question. The question asks, find their ages. So P is Pete's age, that's 9. P plus 6 is 9 plus 6, that's 15, that's Steve's age. P minus 4 is 9 minus 4, which is 5, that has to be Kate's age. Now that one was set up nicely, they all referred to Pete. But we can run into problems that aren't quite so cut and dried, so neat about it. We might have a problem that looks like this. Did you still need that for a second? No. You guys got her? Okay. We might have a problem that looks like this. Sam is 7 years older than Taylor. Drew is 3 years younger than Sam. The sum of their ages is, is 44. Find their ages. So here we've got Sam, Taylor, and Drew. And once again, we are looking for their ages. Sam is 7 years older than Drew, or older than Taylor, sorry. Sam is 7 years older than Taylor, which means we're going to let Taylor equal T. Sam will be T plus 7. Here's the tricky part, though. Drew is 3 years younger than Sam. Not 3 years younger than Taylor, but 3 years younger than Sam. Well, Sam is T plus 7. Drew is 3 years younger than that, so we subtract 3. So t plus 7 minus 3 can be reduced to t plus 4. Positive 7 and minus 3 is a positive 4. So we go to combine these. They add up to 44. Sam's age, which is t plus 7, plus Taylor's age, which is t, plus Drew's age, which is t plus 4, adds up to 44. Then what do we do? Well, we combine t, and t make 3t. Combine the 7 and the 4 to make 11. So 3t plus 11 is 44. Now the variable only appears on one side. Everything is combined, so we can go ahead and solve by subtract 11. 3t equals 33, and divide by 3. So t equals 11. So now we go back and answer the equation. T is 11, that's Taylor's age. Sam is t plus 7, so 11 plus 7 is 18 for Sam. And Drew is t plus 4, so 11 plus 4 is 15 for Drew. What do you think? Not so bad? I'm going to have you guys try one. Pat is 2 years younger than Alex. Chris is 5 years older than Pat. The sum of their ages is 49. Find their ages. I'll give you a few minutes in your notes to figure. Okay, so let's see how we did. So we've got Pat, Alex, and Chris. We are looking for their age. Pat is 2 years younger than Alex. So let Alex be A, Pat is A minus 2. Chris is 5 years older than Pat. Pat is A minus 2, Chris is 5 years older. So plus 5. Which means Chris is negative 2 and positive 5 make positive 3. That's A plus 3. So now if we put those all together, they add up to 49. So Pat's age is A minus 2 plus Alex, which is A, plus Chris, which is A plus 3, adds up to 49. A, and A make 3A. Negative 2 and 3 make 1 equals 49. And now we can start to solve that by subtract 1. 3A is 48, and then divide by 3. A equals 16. So A is 16. That's Alex's age. Pat is A minus 2, so 16 minus 2 is 14. That's Pat's age. And Chris is A plus 3. 16 plus 3 is 19 is Chris's age. Any questions? Okay. So there's all sorts of problems like that that refer kind of back to same information and use a formula. So next, we want to go back and we want to review our algebraic numbers. And as you recall, our place values for whole numbers, actually I should say they're integers, well, not even integers, just with our real numbers, we had that first place value is the ones place, which is 10 to the power of 0. Second place value is the tens place, which was 10 to the power of 1. Then it was 10 squared is the hundreds place. 10 to the power of 3 is the thousands or 1000s. 10 to the power of 4 is the 10,000s, and so on. And we said we could take a number like 6,382 and write it out in expanded form as 6 1000s, or 6 times 10 to the third, plus 3 10 to the second, so 3 times 10 to the second, plus 8 times 10 to the first, so that's just 8 times 10, plus 2, 10 to the 0 is just 1, so we're just going to put plus 2. And with that in mind, we can see a parallel between our real numbers, our whole numbers, and five x to the third plus 7x squared plus 2x plus 8. We can see that this algebraic number has the same place value system as our whole numbers, except instead of being powers of 10 for our place values, in the whole numbers, it's now powers of x. Now, because of the way our whole numbers are set up, we have the larger power first and we go down to the smaller power. We tend to do the same thing with our variables. Larger power of the variable first, going down to the smaller power. That is what we refer to as descending order. Now, these algebraic numbers are often given a name called polynomials. There's a lot of vocabulary that goes with polynomials, like the terms. Terms are just the digits. This has 4 digits, it's 4 terms. There's also something called the degree of a polynomial. That's just the largest power of the place value. So this is the third power on x, x to the third. So that has a degree of 3. Now, we typically don't worry a whole lot about the degree, in this class at least. If you're going to go on to like a college algebra class or even an intermediate algebra class, you would worry about that degree because that degree tells you how many solutions there are to that equation if you set it equal to something. So a power of 3 means there's going to have to be 3 separate solutions to it. We're not getting into that in here. Of course, there are special names for these. Monomial, what does mono mean? Single or one. That just means it's one digit. We've worked a lot with monomials. 7x is a monomial. 8 x to the 5th, y squared, z to the 9th. That's a monomial. Only one digit. It has 3 different place values, 3 names, but it's a single digit. Then, of course, there is the binomial. Bi means 2. So it's 2 digit. We've seen quite a few of these as well. 3x minus 7 is a binomial. 5x plus 2 is a binomial. 8x to the 5th y squared minus 7 x squared y to the 4th. That's a binomial, only 2 digits. And it keeps going up bigger and bigger. We have the trinomials. Which of course is 3 digits. Trinomials will typically take on the appearance of like 5x squared minus 3x plus 7 or something like that. And as we get bigger than a trinomial, we usually just say like a 4-term polynomial or a 5-term polynomial, and so on. We're not going to work with too much more than 3 terms in here, just because that's the extent of the course. Okay, that brings us up to 9:21, so it is our break time. So let's go ahead and take a quick break. Okay, so let's get back to rolling here. So why are we reviewing these place values and polynomials and stuff? Well, because I want to take some time now to go back over our operations with polynomials. We'll go quickly through addition and subtraction. Something like we might have 5x squared minus 7x plus 11. Remember, there's two things that are very different about these algebraic numbers from our whole numbers. The first we might notice right here, the 11. We can have a digit larger than 9 in a single place value. We could have 3 or 4 digits in that place value, actually. Then we could have 572 ones or 572 x's or whatever. So we're not limited to 0 through 9 for each place value. The second is in our integers, either every digit of the number is positive or every digit is negative. Well, here you can see these 2 digits are positive, but that minus 7x is a negative. Each digit in an algebraic number can be positive or negative on its own. So let's say we're going to add that to 3x squared plus 5x minus 8. The process of adding our algebraic numbers is the same as the process for adding whole numbers and integers. We line up the digits. So 5x squared minus 7x plus 11. And underneath that, I'm going to write the 3x squared goes underneath the 5x squared. The positive 5x goes underneath the negative 7x. And the negative 8 ones goes underneath the positive 11 ones. And we are adding here. So just like any other addition, we will start on the right and work our way back to the left. And we've already seen that we don't have to do it that way, but we're going to. The difference is we have to deal with positives and negatives in each digit. 11 plus negative 8 is what? Positive 3. Very good. Now here we've got negative 7 plus 5, which is negative 2x. And 5x squared plus 3x squared, 8x squared. So very, very similar to any other addition we've ever done. Subtractions where it can get rather confusing because of the positives and negatives. We might have 3x squared plus 7x minus 12 minus 6x squared minus 9x plus 4. So we line these up. 3x squared plus 7x minus 12. The 6x squared goes underneath the 3x squared. The negative 9x goes underneath the positive 7x. And the positive 4 ones goes underneath the negative 12 ones. Now we have to remember this is subtraction going down each column. So we have negative 12 minus 4. Where negative 12 minus 4 becomes negative 12 plus a negative 4. So negative 12 plus a negative 4 is negative 16 ones. 7x plus negative 9x. 7 plus negative, 7x minus negative 9x. So 7 minus a negative 9 becomes 7 plus a positive 9, which is positive 16x. And 3x squared minus 6x squared, negative 3x squared. I remember it's subtraction. Those can be kind of tricky because of the negatives. I'm going to have you guys try one. Five x squared minus 11x plus 2 minus 7x squared plus 3x minus 9. I'm going to have you give that a shot quick. Okay, so we'll write this out. 5x squared minus 11x plus 2. The 7x squared goes under the 5x squared. The positive 3x goes under the negative 11x. And the negative 9 ones goes under the positive 2 ones. And we are subtracting. So 2 minus the negative 9 becomes 2 plus a positive 9, which is positive 11. Negative 11x minus 3x. That's negative 11 minus 3 becomes negative 11 plus a negative 3. So negative 11 and negative 3 make negative 14x. 5x squared minus 7x squared, negative 2x squared. What do you think? Not so bad so far, right? Okay. We've done a lot of multiplying monomials, even with multiple names like 7x to the 5th, y to the 3rd times 5x to the 4th, y squared. Where we combine the counts. 7 times 5 is 35. And then we combine each name separate. X to the 5th times x to the 4th. X to the 9th. Y to the 3rd times y to the 2nd. Y to the 5th. So 35x to the 9th, y to the 5th. We've actually even done quite a bit of the single digit times a double or triple digit. Like, just like 5x squared y times 3 x to the 5th y squared minus 7 x to the 3rd y to the 3rd. Where we'd multiply 5x squared y times 3x to the 5th y squared. Multiply the counts. 5 times 3, 15. Then each name, x squared times x to the 5th, x to the 7th, y times y squared, y to the 3rd, 5x squared y times the negative 7x to the 3rd y to the 3rd. Well, 5 times negative 7, negative 35, x squared times x to the 3rd, x to the 5th, and y times y to the 3rd, y to the 4th. Good. And we can multiply by even longer numbers than 2 digits like that. We might have 7 x to the 3rd y z squared times 5 x to the 5th minus 8y to the third plus 2xz to the fourth. So as we multiply here, the 7x to the third yz squared times 5x to the fifth. What do we get? Seven times 5 is 35, yep. For x, x to the 8th, good. X to the third times x to the fifth is x to the 8th. And then, there's nothing to combine with the y or the z squared, so they just stay the same. Then 7x to the third yz squared times negative 8y to the third. 7 times negative 8 is negative 56. Nothing to combine with x to the third, so it stays the same. Y times y to the third is y to the fourth. And again, nothing to combine with z squared, so it just stays z squared. And then the 7x to the third yz squared times 2xz to the fourth. Positive 14 is 7 times 2. X to the third times x is x to the fourth. Nothing to combine with the y. Perfect. Z squared times z to the fourth is z to the sixth. Not so bad. Our next step was to look at things like this. X plus 5 times x plus 2. Now we said we could multiply these out just like any other number. We can write them out and multiply. We have 2 times 5, which of course is 10, positive 10. 2 times x is 2x. We're finished with that digit, so we're going to move over to the next one. So I'm going to leave a blank down here. X times 5 is 5x. X times x is positive 5x. X times x is x squared. And then we can combine those columns, the digits. We've got the 10. 2x and 5x makes 7x. And then we've got x squared. But there was a shortcut that most of us were taught. The FOIL. F stood for first. X times x is x squared. O stands for outer or outside. We multiply the outside numbers. X times 2 is 2x. I stands for inside or inner. 5 times x is 5x. I'm going to drop down and write that there so I can combine those. And L stood for last. 5 times 2 is 10. So now we can combine. We've got the 10, 2x and 5x make 7x, and the x squared. So we get the same answer either way. This here, the FOIL method, is probably a little bit shorter. And those can get a lot more complicated. We might have 3x minus 7 times 5x plus 2. We're going to follow that same process. 3x times 5x is 15x squared. Good. 3x times 2, positive 6x. Negative 7 times 5x. Negative 35x. Now we could have just kept going and writing it over here, but I want to put it under the 6x so that I remember to combine them. Negative 7 and 2 make negative 14. And then I'll combine. Got my negative 14. 6 and negative 35 make negative 29x, and we have the 15x squared. Let's have you guys try a couple of those. We'll start you off with, let's get back here. This one, 4x plus 7 times 3x minus 5. Well, let's try that one. We'll go over it. Okay, so for this one, 4x times 3x is 12x squared. 4x times negative 5, negative 20x. 7 times 3x, 21x. And 7 times negative 5, negative 35. So we combine here, we've got the negative 35, negative 20x, and positive 21x is just positive 1x or just positive x, and then 12x squared. So if you put the 1 in front of the x, that is fine as well. Now, we can also advance to a little bit longer numbers here. We could have 2x plus 5 times 3x squared minus 9x plus 11. Now, if we were to write this out the long way like we did some of those, it works just like any of the others. You did the 5 times each digit, then you did the 2x times each digit. But that takes up some space. So we can go back and we can do our shortcut, our FOIL. We just have to modify it because there's extra digits. It's just 2x times 3x squared, which is 6x to the third. 2x times negative 9x is negative 18x squared. 2x times 11 is 22x. Now we move to the next digit. 5 times 3x squared. It's a positive 15x squared, so I'm going to put it under my negative 18x squared. 5 times negative 9x. Negative 45x. Again, I'm going to put that under my other x's. And 5 times 11, positive 55. So now we add, we've got 55 here. 22x and negative 45 make negative 23. Negative 18x squared and positive 15x squared, negative 3x squared, and 6x to the third. Not so bad? How about you guys try one like that? 3x minus 7, 2x squared minus 5x plus 3. I'll give you a couple minutes. Okay, so we'll start out with the 3x times 2x squared, which is 6x to the third. 3x times the negative 5x, which is negative 15x squared. And 3x times 3, positive 9x. Now we move to the next digit. Negative 7 times 2x squared. Negative 14x squared. Negative 7 times negative 5x. Positive 35x. And negative 7 times 3. Negative 21. So we've got the negative 21. 9x and 9x and 35x make 44x. And negative 15x squared and negative 14x squared make negative 29x squared. And, excuse me, but the 6x to the third. Any questions on that? Well, then, just for fun, let's see if you can figure this one out on your own. (5x squared minus 9x plus 3 times 2x squared plus 11x minus 8. See what you come up with there. Okay, so let's take a look. You guys need another second to finish this up? Yeah, okay. Okay, let's see how this one's going. So we start out with 5x squared times the 2x squared, which gives us 10x to the 4th. 5x squared times the 11x, 55x to the 3rd. 5x squared times negative 8, negative 40x squared. Good. Now we move to the next digit. Negative 9x times 2x squared, negative 18x to the 3rd. Good. Negative 9x times 11x, negative 99x squared. And negative 9x times negative 8, positive 72x. And on to the last digit, 3. 3 times 2x squared, positive 6x squared. 3 times 11x, positive 33x. And 3 times negative 8, negative 24. Now we have some combining to do. Negative 24 is by itself. 72x and 33x is positive 105x. Now we've got negative 40 and negative 99 is a negative 139. Plus 6 is negative 133x squared. 55x to the 3rd and a negative 18x to the 3rd is a positive 37. Good. X to the 3rd. And then the 10x to the 4th. We're not going to go any more difficult than that. I am going to step back for a second and look at these again. 2x minus 7 times 3x plus 5. And we're going to do the 2x times the 3x, of course. It's 15x squared. 2x times the 5 is 10x. We have negative 7 times 3x is negative 21x, and negative 7 times 5 is negative 35. Now, before I add these, I want to take a look at where things came from. The 15x squared, that's from the F in FOIL, the first digits, the 2x and the 3x. The 10x, that's from the outside, the 2x and the 5. The negative 21x is from the inside, the negative 7 and the 3x. And the negative 35 is from the L, the last, the negative 7 and the 5. Now I'm going to combine those. I've got the negative 35 here. I have 10x and negative 21x is a negative 11x. And I have the 15x squared. You can see how this still stacks up. The 15x squared is still just the first digits. The negative 35 is still just the last digits. And that negative 11x, that's from the outside plus the inside. So we see where each of those digits comes from. On Wednesday, what we're going to look at is now reversing that process. If we know that this digit had to come from a combination of these two, how did I do 2 times 3 and get 15? Maybe that should be 6x. That might make more sense. 6x squared. Sorry. If I know that that digit, the 6x squared, had to come from a combination of these two, I can work backwards to figure out what those digits are. There's only a couple of possibilities. That could be 3x times 2x, or it could be 6x times 1x, or just x. If I know the negative 35 came from a combination of the last digits, the negative 7 and the positive 5 in this case. Well, negative 35 has only so many possibilities. It could be negative 7 times 5. It could be 7 times negative 5, or negative 1 times 35, or 1 times negative 35. Only so many possibilities that multiply to give me a negative 35. And then how do we know which one of each of these possibilities we're going to use? Well, this middle digit has to work out to be whatever the outside digits are plus the inside digits. So we can double check to see if that works out. So that's what we're going to do on Wednesday. Well, because of the test last class, there is no new quiz. I have your test for you. I'll give it to you in just a second. But there is a new homework. It'll be due for Wednesday. The computer lab next door is open if you want to get started on your homework. I'll be here to help you out till about 10:20.